653 has 3 significant figures. 0.0054 has 2 significant figures because the first significant figure is the 5, which appears after multiple zeros. 5.038 has 4 significant figures even though there's a 0 in the middle because there's already a significant figure before that, which is the 5. So that is for significant figures. Standard form is what you get when you try and simplify decimals like this. For example, it is in the form of a times 10 power n. For example, 3.4 times 10 power 3. The only condition that you have to fill is that a has to be less than 10 but more than 1. It cannot be in a 0 point blah 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 decimal form. It cannot be in the tens form. It has to be in the ones form or in ones with a few decimals at the back. So most of the questions that involve scientific notation, or also known as standard form, will include subtracting or adding two figures together. So to do that, we need to do something called factorization. But if you want to get factorization, we need to make the 10 power n at the behind it the same. For example, here we have 10 power negative 9 and 10 power negative 10. So how do you do that? You have to apply the multiples of the multiple rule, where if you have two of the same or if you have two of the same base value with a different power, it will equal to the base value powered by the two powers added together. So we know that minus 9 it can be equal to minus 10 plus 1. So with that in mind, we can separate them. We can multiply these two together to get 29. And now we have the same powers. And now we can use factorization, factorize these two, subtract the other, and then after that convert it back into standard form.